In this part of the lecture, we are going to give you a summary of what we have learned thus far in relation to automated process discovery, and in addition, I am going to give you a demo of how I would approach process discovery given an unknown event log. But to begin with, process map complexity. As we remember, process mining tools use process maps as the main visualization technique for event logs. However, full process maps can be very large and complicated, thus requiring simplification, and this is usually done through process map abstraction and event log filtering. Now, some examples of process map complexity. What you have on the screen right now is the full sepsis cases event log, all the pathways in that log. It looks already quite complicated, however it is far from the most complicated event logs out there. In fact, here is another example where you have a mess of arcs and activities. It's going to be very tricky to work with the full log, so you kinda need to apply, for example, process map abstraction. So common process mining tools provide abstraction capabilities to simplify process maps. This is usually done by showing only the most frequent activities or the most frequent arcs, and this allows us to get from a messy process map to something that is easily workable. Other tools offer further abstraction capabilities to, for example, show least frequent activities, least frequent arcs, fastest, slowest activities, or fastest, slowest arcs. And this is usually achieved via the use of simple sliders. The other aspect is filtering. Here I have a list of the main filters that can be used to filter cases. We have case variant filters, case ID filters, attribute filters, and time frame filters. Additionally, we can use, of course, performance filters, path filters, and rework and repetition filters. I will not be going over all of them in this summary part of the lecture. However, what I want to emphasize and what we haven't discussed before is event filters. So in addition to removing some cases from an event log, it is possible to actually strategically remove some events from the event log. This can be done via using attribute filters, time frame filters, or between filters. And the important thing to realize here is that removing an event from an event log doesn't necessarily remove any cases. What event filters allow you to do is to focus on a specific part of the process control flow. For example, if your process has a well-known sub-process that begins with a specific activity and ends with a specific activity, then you can use the between filter to focus in on that sub-process alone without looking at other parts of the event log. And finally, since the automated process discovery is quite complicated, here is a small analysis template that pretty much applies to any event log that you are going to analyze. On the left-hand side, you can see what are the steps that you would normally like to do. For example, you would like to do flow analysis. This is analysis of the process structure and main case variants. Additionally, you want to identify parallelism, branching points, and rework loops, and analyze case entry and exit points. You might want to do filtered flow analysis. This is analyzing different components or slices of the process separately. You might want to do frequency analysis. This is analysis of the most frequent activities and relations. And finally, you might want to do handoff analysis, assuming that your event log has information about resources. Because resources can form a bottleneck of their own. For example, if one team in your process is heavily overloaded, then this can have significant consequences to the overall control flow and performance of the process. However, now it is time to give you a demo of how I would approach analysis of an unknown event log. For this demonstration, I am going to be using the same sepsis cases event log that we have used previously, While we are already familiar with this log, the steps that I'm going to show you are going to apply to any other log. So first of all, I would actually not start with the process map itself, but I would start with looking at how many cases I have and how many case variants I have. Because this ratio kind of gives me the variability. So how much variability there is in the process. What it kind of means is that if the variability ratio is high, then it indicates to me that the process is either not very well standardized or there are cases of parallelism in this process. Then after that, when I understand the flexibility of the process or how variable the control flow of the process is, I would also take a look at how many activities does the process have. So how much stuff is actually done in this process. After that, I would also take a look at the case durations. So what is the cycle time of the process in general? And what is the log time frame? So what is the time frame into which all of those cases are going to fall? It can be useful in some cases where you suspect that your process might have some seasonality. For example, if you see activity names that kind of indicate a web store, then you would like to see if the log time frame falls into the area of Christmas. Now, once I have an understanding of the statistics, I would start going over the process map itself. And at this stage, I would try to get an understanding of how the process looks like in general. In this case, I have ER registration, followed by ER triage, followed by sepsis triage. And based on the case frequencies, compared to the number of total cases, I can be relatively sure that those are going to be executed in every case, and most likely in the given order. But after ER sepsis triage, I can see that the outgoing arc covers only 285 cases. This kind of tells me that there is some information missing here. However, at this stage, I will not be too worried about it yet, because I want to go over the entire process. So I would look at what are the other points of the process that might be interesting. For example, a decision point here or a decision point here. And I would also take a look at what are the exit points of the process. And here I can see that we have release A, followed by return ER, release B, release C, release D, release E. So this tells me that there are a number of exit points to the process which I can take advantage of in a later stage. The next thing I would look at is how the main case variants look like, or even if there is a main case variant. And in this case, if I open the filtering view, I can already see that there is one case variant that occurs 35 times. So I would probably just deselect all of them and take the, let's say, first 5. And this already, you'll note that this alone is going to cover 10% of all the cases. I'm going to click OK, apply the filter, and look at what is the process map that I'm going to get. Given that it's quite a simple process map, I will add all the arcs in. So here what I can see is that those cases, they kind of seem incomplete because the release types are missing. Some cases occur or finish right after ER sepsis triage, some after IV antibiotics, some after leukocytes, and so forth. Based on this, I would deduce that I have incomplete cases. And those I would probably exclude from the further analysis. Again, not always. Depends on what is your current analysis tasks, what is the actual business questions that you are trying to answer. But in general, you might want to exclude incomplete cases. And to do that, I would first of all clear all the filter criteria. Now I'll get a mess, but I can easily clean this mess up. And I would go back to filtering. And what I would do, I would just filter based on the attribute in this case, sort it by name, and keep the release types. Because I have already identified that those are kind of the endpoints of the process. Additionally, I'm going to keep return ER just in case, because it was one of the main exit points, in addition to release types themselves. If I click OK, OK again, then I'll get a process map that doesn't look much different than before. However, of course, note that the variability ratio, interestingly, has now gone up. And this is because I have removed quite a lot of cases where only the first 3 steps had been done. So it's kind of reasonable that now I have a bigger proportion of cases where this decision point kind of matters. And additionally, I can note that the case durations have also changed. So the next step that I would probably do, I would add in a bit more arcs. I would go to 20 first and see what I can see. The process map doesn't look too much more complicated, but I can see some semblance of potential reworks or maybe parallelism. However, given that the process map itself isn't too complicated yet, I would probably go a bit higher even, to 30. Now this is maybe a bit too much, but honestly, you can work with it easily. And now that if I wanted to continue analyzing this process map, one thing that I would look at is per activities. If there is an activity that I'm interested in, or a decision point that I'm interested in a process map, I would try to figure out if all the outgoing arcs are represented. Because as you remember before, for ER sepsis triage, let me go back for a brief moment. After ER sepsis triage, we have here 237 cases represented by this arc. However, ER sepsis triage itself occurs in 781 cases, considering the filters, of course, as well. Then this tells me that there is something missing. So I would like to go up to, let's say, 30. And now I would try to figure out if most of the cases that reach ER sepsis triage, if the following steps are actually now represented. I have 128 here. I have 237 here. Almost 200 here. And 131 here. Something is missing, if my math is correct. But most of it is already there. So this is something that I'm quite happy with. Additionally, I would look at the existence of self-loops, because these tend to be reworks, which tend to be issues with process performance. And additionally, I would look at if there is any back and forth like this, which can be parallelism, but can also be a potential rework. And I would probably take a look at loops. For example, here, admission NC, going to CRP, going to leukocytes, and going back to admission NC. So I would try to look at those loops, and whatever I find interesting in this process map, I would try to apply filters in order to focus in on those specific cases containing that specific relation between activities. For example, I would like to see CRP, and all the cases where CRP is directly followed by CRP. And this can be easily done via path filtering. Now another part that I would try to do, I would actually go back a bit with the arcs. So I have a clean map again, and I would look at the durations. Now here I can easily see that all the activities have an instant duration. This tells me that the event log had one timestamp per activity or per event. But based on that, I could look at what are the durations here. I can see 42 minutes. I can see 4.77 hours. However, all the arcs, the thickness of the arcs is quite low. So this kind of already indicates that somewhere in this process map, I have an arc that is going to be really slow. And indeed, if I go here, I have an arc that is 2.71 months. And it kind of indicates to me that perhaps if I wanted to gain a better understanding or make my life easier analyzing the durations in this part of the process, then what I would actually like to do, I would go to the filtering view, I would actually add another filter, and this time an event filter, and I would just remove return ER. Now, of course, later on, I might want to put return ER back, but for now, I'm going to remove it from the process map. And now I can more easily understand where are the most or the longest durations in the process. Now those are already easily visible. I have one after CRP going to release D, one going to release C. And also in here, I can see that those arcs now are a bit more visible than they were before. Now in doing that, when doing that, I could of course continue on further, and one of the additional things that I would like to do is to change the abstraction settings. I would go abstracting by average duration, and in here I would probably change the ordering as well in order to keep the slowest arcs. And now this kind of allows me to see that, for example, admission NC, there is 1.26 weeks before release C. But there is also CRP test, after which in 4.59 days release C occurs on average. So this kind of allows me to see the potential bottlenecks of the process. Of course, I would look a bit deeper into the process map itself, probably with even more arcs, probably focusing on different sublogs or different sets of cases in the event log, but this is a very useful way to proceed. And the final thing that I would actually take a look at is the resource view. If I have resources available, I would take a look at how the process map, or more specifically, the process map with the duration overlay looks at between resources. Now, unfortunately, in this log, it seems that all of the resources also have an instant duration. This is, of course, because I don't have end timestamps of the events, or, excuse me, start timestamps of the events in the event log. However, even in this map, I can see some, let's say, potential delays in the process. Now, it might be the case that this resource here is overloaded. It kind of seems to play a central role in the process because there is a lot of incoming arcs to this specific resource. However, it might just be a reason of how the process control flow itself looks like. But in any case, this is something to be looking for and to be pointed out when you're presenting your, let's say, analysis report to the user or the business user. Additionally, if instead you had 2 timestamps per activities, then here you would also like to see the resources that take the most time. In some cases, they are just working with the hardest process instances, but in other cases, they might be just slacking off. So this is also something that you can see on this process map. Now finally, one more thing that is worth a mention when I go back to the activities view is actually looking at the specific process instances. So in here, when I click on the number of cases that I have, I get a case inspector. Of course, I can filter it here, let's say by duration, or sort it here by duration, for example. And let's take one slow. It has 185 activity instances. So this is quite a surprising case. And as we can see, it is a long chain. If we zoom in, then here we can clearly see what is actually happening. It's ER registration, also with all the event attributes that are present in the log. And then we can see ER triage, sepsis triage, leukocyte, lactic acid, admission, leukocyte, admission, and so on. We can see that there is a lot of repeating activities. This is probably a complicated treatment procedure, or maybe even a complicated treatment process. At least we don't see any additional return ERs or ER registrations. So this is probably a long treatment case. If we look at other cases, we can see a bit easier ones, or we could even sort it by activity instances and see a short one, where we have just ER registration, triage, sepsis triage, admission NC, and release A. So this can be a very useful tool in some cases. There are, of course, some additional filters that you can apply. There are additional views that you can take, and so on. But these are kind of the main steps that to get you started. Once you have followed through with all of those steps, then I am 100% certain that you will have further ideas at what to look for in the following analysis steps.